When physicists talk of waves, they always make it seem like different waves are described by different branches of physics, classical and quantum. Today, I would like to show you that all waves are just waves, and that the energy of all waves is quantized, not only the energy of EM waves. I will show all this mathematically, and you will see how Planck's quantization equation E equals nhf will come out naturally, and also how the dependence of wave energy on the square of the amplitude also comes out from the same result. After that, it will become clear to you why physicists were inclined to think that those two relations of energy are fundamentally different and should fall under two different branches of physics, classical and quantum physics, when in fact the two equations are equivalent. This will go further to support my claim that quantum mechanics is wrong, something that I have been proving from every corner of physics since the beginning of this channel. To demonstrate beyond any reasonable doubt that the expressions I will come up with are correct, I will use them to make a prediction. I will predict the density of empty space, and then compare what I get with real data, which is about 1 hydrogen atom per cubic centimeter, and you will see the level of accuracy in the prediction. I will also use the expressions to calculate the fine structure constant, alpha, and prove that it is consistent with the definition given in quantum electrodynamics, QED for short. That is, it is the constant that tells us how strongly the photon interacts with an electron, and mathematically, using my expressions, I will derive this as the force of an electron equal to alpha times the force of a photon. I will also go further to express the density of free space as a function of the fine structure constant. It will be a long ride, so you might want to grab a cup of coffee before we start. All what you're going to see, just like everything you have been seeing in the other videos, is entirely my work, and I shall soon be publishing. So you are free to criticize in the comment section below, but please mention a reason to back your criticism. I guarantee you that you won't be able to spot any math or physics errors. But in case you do, please let me know in the comments. To see more proofs like this one, which simplifies all modern physics for you, click on that subscribe button, as there is more to come. When Planck wrote his E equal nhf equation, he didn't have any mathematics or physics to back it. He simply just guessed the equation because all other attempts to solve the blackbody problem had been futile. Up till today, there is no first-hand derivation of the expression until when I derived it in my other video titled Schrödinger equation of planet basics. Until I derived that expression, this equation was always fascinating, but after you watch that video, you will see that it is not. I am going to show you that it is even less fascinating by deriving it again using water waves. So let's do that. Let's consider a wave on the surface of a liquid of density ρ produced by a point source. I would like to find out how much energy will go through a surface bounded by a circle of radius r. We can place an energy detector on this surface to record how much total energy reaches the surface in a given time. As you can see, there are many cycles of the wave structured like concentric loops of wires of cross-sectional area little a. The radius of cross-section is the amplitude of the wave. So the cross-sectional area little a is equal to pi times capital A squared, which is pi radius squared as you know it. For an infinitesimally small portion of the wire, we can define a volume element dV as area times dx, which is equal to pi radius squared dx. Mass can be written as a function of density as this, such that the mass of this small portion of the wire, dm, is equal to rho dV. But dV is pi radius squared dx, so dm is equal to rho times pi radius squared dx. Remember that we are dealing with a wave on a liquid with uniform density. This portion of mass, as well as all the other portions, is moving with velocity v from source to detector, so it must carry kinetic energy. Note that the speed of a wave on a liquid of constant density and depth is constant. Kinetic energy is defined as half the mass times the velocity squared. For our small mass dm, the kinetic energy dE is equal to half dm times v squared. Subbing in the expression for dm yields this. To get the total energy of the whole loop, that is the total kinetic energy of this one cycle of the wave, we integrate over the whole length of the loop, which is the circumference of the loop. So, E is equal to the loop integral of half pi rho a squared v squared. This gives us half pi rho a squared v squared times 2 pi r, where r is the radius of the loop centered at the point source. This simplifies to E equal rho r pi squared a squared v squared. In some time little t, a given number of cycles n would have been produced, whose energies would have been measured by the detector. So the total energy recorded by the detector will be equal to the number of cycles times the energy of one cycle, which we have calculated already. So the total energy recorded in time t is given as follows. We know that frequency is defined as the number of cycles made per unit time. So the number of cycles is equal to F times t. Our total energy becomes Ft rho r pi squared a squared v squared. Let us play around with this expression just a little. First, we multiply and divide by 2 and write pi squared as pi times pi, so that we can have 2 pi f in the numerator. This is the angular velocity omega, so E is equal to this. Next, we can write v squared as v times v to have this. But v is equal to omega r, so we replace one of the v's with this expression to have this. We see that we have omega times omega, which is omega squared, and r times r, which is r squared. So E is equal to this. But what is pi radius squared? It is the area of a cycle of a wave of radius r, as we saw in the beginning. Since all the waves vanish at the detector, we can just let this radius be the radius at the detector position. It doesn't really matter how far from the source the detector is, because the total energy flux will be the same. So let's denote this area as A prime. So the energy becomes half omega squared A prime rho T A squared V. But area times the volume density is the linear density mu. So E is equal to this. The rate of change of the energy with respect to time, dE dt, is therefore half mu omega squared A squared V. This is the power equation of transverse waves. Therefore, it is undisputable that the method used is correct. Looking superficially at this equation, you can say, well, that is the classical expression for energy that I already know. So where does the word quantum come in? Let's go a bit deeper. We know that omega is equal to 2 pi times the frequency. So omega squared is equal to 4 pi squared f squared. Let's write f squared as f times f to have this. But f is the number of cycles per unit time. If we replace one of the f's by this expression, we have omega squared equal to this. I am using this form of the energy equation because I prefer to use volume density because it is more realistic. Linear density is just a model. If we submit the expression for omega squared, we get the following blue expression. T will cancel out and we are left with this. Provided there is no energy loss, the total energy going through any closed area that encloses the point source must be constant. That is, the net energy flux through any closed surface that encloses the point source is constant. So, let's choose a simple number of the area so that our equation will be simpler. So let's choose A prime equal to 1 meter squared. E becomes n times 2 pi squared rho v A squared times f. The speed of a wave in a medium is constant. So let us equate all the constants in this expression to a single constant k as follows. So E becomes nka squared f. Let us take the case of a ripple tank experiment. The frequency of the wave is constant, but the amplitude drops as the wave spreads. So in this case, f is a constant, and so we can write the energy as nk prime a squared, where k prime is equal to k times f. Now you see how the energy of the wave is proportional to the square of the amplitude. This is what they call the classical wave theory, and refer to this as classical physics. So far, I have made no assumptions or introduced any new concept or theory. I have simply done pure math, and math doesn't lie. If you like what I have done, please give the video a thumbs up. And if you wish to see more videos like this, then click on that subscribe button. If you think there is any error in the presentation, please drop it down in the comment section. I respond to all comments. Moving on. Let us take the case of light. According to Maxwell's theory, which is also a classical theory, light is a combination of electric and magnetic fields oscillating perpendicular to each other. Their respective expressions are given as follows, where E0 and B0 are the amplitudes of the electric and magnetic fields respectively. Note that these values are constant. Therefore, the amplitude of light, which is a combination of these two fields, is also constant. But we also know that the frequency can change. That is why we have different colors of light and also different EM waves. So, in our energy equation, A squared is constant, while F is variable. So we can absorb A squared into the constant K to have K prime prime equal to Ka squared. So the energy becomes E equal Nk prime prime times F. This is the Planck quantization equation, where K prime prime is equal to h, the Planck's constant. In the last videos on gravitational and EM wave, we saw that EM waves, like gravitational waves, are oscillations in a medium called spacetime. The density of this spacetime medium is near zero, so the damping factor is really negligible. That is why for a long distance, the amplitude of the light appears constant. But that cannot exactly be correct, because as the wave spreads from the source, the number of particles that oscillate increase with an increase in the spreading area. And so, particles further away should have less and less energy so that the total energy remains the same. So if the source is of a constant frequency, then the amplitude must drop as you move away. I think you observe that phenomenon every day when you touch a water surface. So we see that Planck's equation is in the limits of appropriate distances. This is why light from very distant galaxies may never reach us, and is why we coin terms like the edge of the universe, because there is a limit to how far we can see. This directly makes the theory of the Big Bang questionable. Tell me what you think. I guess now you see how the word quantum comes out from this model. But because physicists could not derive this Planck's equation and express the energies as I have done, they tend to think that energy being related to amplitude and energy being related to frequency should form different branches of physics. But now you see how quantum physics gets absorbed into classical physics, don't you? What this is telling us is that light has a medium through which it propagates, and this medium has a density. I have also proven this statement in the series titled Gravitational and EM Waves. You can check it out under this playlist, Waves and Particles. If you take away the idea of a medium for light, then you are also directly saying that the equation E equals mhf is wrong, as well as the idea of a photon. And you will be left only with the classical expression for energy, E equal nk prime a squared, which cannot explain the so-called quantum phenomena, and you get back right where you started. So there is no choice. If you must accept the Planck's equation, then you must also accept the idea of a medium for light. Now, looking at the equation E equal nk prime prime f, we see that k prime prime is equal to h in the case of light and other EM waves. But k prime prime is equal to 2 pi squared a prime rho a squared v. Remember, we had chosen a prime to be equal to 1. I am just bringing it in for the purpose of homogeneity of the equation. Since we are dealing with light, then the speed v must be the speed of light c, and the a its amplitude. So h is equal to 2 pi squared rho a prime a squared c. Since c is the speed of light in free space, then rho must be the density of free space. So rho is equal to this, which can be written as h bar over pi a squared. Remember that a prime is equal to 1. Since a is the radius of one cycle of the wave, then pi radius squared is the cross-sectional area enclosed by one cycle of the wave little a, according to what we saw in the beginning. So rho is equal to h bar on AC. This predicts the density of free space, and if we can prove this prediction to be correct, then we must conclude that light has a medium through which it propagates. To calculate the density, we need to know the amplitude of light. Let's take this amplitude to be equal to the bore radius 0.5 exponential minus 10 meters. Subbing this value together with the speed of light and the value of the Planck's constant, we get 0.45 exponential minus 22 kilograms per meters cubed. The density of the cosmos has been measured by many different astronomers, and the majority of them claim the density of free space is around 0.1 to 1 hydrogen atom per cubic centimeter. In kilograms per meters cubed, this gives 1.3 to 13.4 exponential minus 22 kilograms per meters cubed. Others have measured the density to be as low as 0.06 hydrogen atoms per cubic centimeters, which is equal to 0.8 exponential minus 22 kilograms per meters cubed, while others have measured it to contain up to 1,000 hydrogen atoms per cubic centimeter. So astronomers do not yet have an absolute value, but rather a range of values. Also, how high light oscillates, we don't really know. So we can just also define it as a range. Let's place it between 0.1 to 1 of the bore radius. Using the bore radius, we already saw that my formula yields a density of 0.45 exponential minus 22. An amplitude of 0.1 of the bore radius will yield a density of about 45 exponential minus 22 kilograms per meters cubed. So you see that the range of values of the density produced by my formula will contain all the values that astronomers have attempted to measure, meaning that if we know the exact value of the amplitude of light, we can get the exact value of empty space. Therefore, my prediction is correct. If we stick with the amplitude of light being equal to some multiple of the bore radius as we have used to calculate the density, we can explain the observations of dark matter and the fine structure constant alpha.